So in the last video, we thought a little bit about what ought to happen when you and Wilma interact, right? And essentially what we concluded is that without saying anything else, all we should be able to conclude is that you ought to end up on your contract curve, right? You ought to end up somewhere where there's not a way to make both of you better off than you are at wherever you land, right? Beyond that, anything we say is a value judgment, right? It has to do with whether we care more about you, care more about Wilma, care more about equality, etc. So what we're going to do here is we're going to think about how the outcomes of a competitive market equilibrium compare to the outcomes that we want to see. And how we're going to do this is we're going to imagine now that rather than just having a you and having a Wilma, we have something like a giant desert emporium where there's 100,000 Wilmas, there's 100,000 yous, you all show up with a wheelbarrow of stuff right into the market. Some market prices exist, right? There's a price of beefaroni, there's a price of Gatorade. You sell all your stuff at the market prices, and then you buy whatever you want, right? So we're going to imagine a situation where each person is going to behave like a consumer in a market economy. This makes sense? Great. So to start off with, let's forget all about Wilma, right? You don't care about Wilma, you care about you. And let's think about what you're going to end up encountering when you show up at this market. Well, what we know in this situation is that, as a consumer, you're going to have some budget and you're going to pick whatever's best for you given that budget, right? We're going to want to draw some sort of a budget constraint for you. Put it over here, right? That looks something like this, where you have the amount of Gatorade down here, you have the amount of beefaroni over here, and you're going to have a slope of this thing that's like the price of Gatorade over the price of beefaroni. Does this make sense? This would be a kind of problem that we're familiar with. So what would this budget be? Right? What's your budget for beefaroni and Gatorade going to be? Well, I'm going to say your budget's going to be on one side, right on the consumption side, it should just be the price of beefaroni times the amount of beefaroni you buy, plus the price of Gatorade times the amount of Gatorade you buy. Right? It has to be less than or equal to your income. So the only question is, what's your income? Right? How much beefaroni and Gatorade can you afford? And what I'm going to say is, your income is just the value of all your stuff. Right? You walked in with, not with a certain number of dollars in your pocket, but with 50 gallons of Gatorade in your wheelbarrow, 700 cans of beefaroni in your wheelbarrow. Right? So what your income is going to be is the price of beefaroni times the amount of beefaroni you have, right? Times 700, plus the price of Gatorade times the amount of Gatorade you have, which is 50. Right? In other words, your income here is going to be the value of all your stuff, right? The value of your endowment. So on this graph here, one thing we know that you can afford is 50 gallons of Gatorade and 700 cans of beefaroni. Does this make sense? Great. Given this budget, which we just figured out, what are we going to know about your optimal choice, right? What are you going to actually do? Well, we know that you're going to pick whatever's best for you, right? You're going to have an indifference curve, a bunch of indifference curves, really. You're going to pick the best one you can achieve, given your budget. This is going to be your optimal choice. Right? If you can buy and sell as much Gatorade as you want, as much beefaroni as you want, you're going to end up picking the amount of beefaroni and Gatorade that's best for you, given your income, right? Given your budget constraint. So we're also going to say what you'll pick, right? Where MRS, assuming for now that we have an interior solution, right? Really, we're going to have all the normal rules of optimization, but your MRS for GY and BY, right, has to equal the price of Gatorade over the price of beefaroni. Actually, it shouldn't be U colored. This makes sense? And you satisfy your budget. So that's what you're going to do. How about Maud? I'm sorry, how about Wilma? What's Wilma going to do? Well, Wilma's going to do exactly the same thing, right? Wilma also has some budget. Right? She's also going to choose some amount of Gatorade, some amount of beefaroni. Right? She's also going to have the same prices, PG over PB. And she's also going to be able to afford her initial endowment, right? She's going to be able to afford 450 gallons of Gatorade and 300 cans of beefroni, right? So Wilma's budget is going to be exactly the same stuff, right? PB times BW plus PG times GW less than or equal to PB times the amount of beefroni she has, right, 300, plus PG times the amount of Gatorade she has, which is 450, right? Exactly the same as you. The value of her income is going to be the value of her endowment. She's going to be able to afford any combination that's as expensive as her endowment. And just like you, she's going to choose where her MRS equals PG over PB. This makes sense? Cool. So what this has done is this has told us, given a particular set of prices in the market, right, given these powerful market forces acting on you and Wilma, we'll know what you're going to do, we'll know what Wilma's going to do, because we'll just solve this as an ordinary consumer problem. So all we need to know now is how we're going to find these prices, right? What else has to be true that's going to bring some order to this situation, right? Where do this PG and PB come from? And the last thing we need to remember, right, the thing that's going to determine this is that there's only so much beefroni in the sea, right? In other words, the total amount of beefroni that you buy plus the total amount of beefroni that Wilma buys has to end up being the total amount of beefroni that exists in the world, right? In other words, what we're going to say is the last thing we're going to say is supply has to equal demand. Right? So this means that your Gatorade plus Wilma's Gatorade has to equal the amount of Gatorade that exists, 500, right? Your beefroni plus Wilma's beefroni has to equal the total amount of beefroni that exists, which is 1,000, right? And these conditions, you making your best choice, her making her best choice, and supply equaling demand, is going to be everything we know to know that the economy is in a competitive market equilibrium. Great. So now let's go about trying to solve this thing, right? Trying to find our values, trying to find out what happens when you and Wilma and all of your clones meet in the market. So the way that I'm going to go about doing this is essentially going to be to think about your problem first, think about Wilma's problem next, to find each of your demand curves for Gatorade and for beefroni, right? In other words, we want to know, at a given set of prices, how much Gatorade are you going to buy? How much beefroni are you going to buy? Right? At a given set of prices, how much Gatorade is Wilma going to buy? How much beefroni is Wilma going to buy? Once we know this, we can find the prices by figuring out what set of prices leads you and Wilma collectively to buy 500 gallons of Gatorade and 1,000 cans of beefroni. So we're going to start by trying to find your demand curves. Right? And just like we did in Unit 1, we're going to do this with our two equations here, right? Our budget equation and our MRS. So we have our budget. So the first thing that we're going to want to do is to find your MRS, right? So we'll say that your MRS for Gatorade and beefroni has to equal du dg over du db, right? Which, as we know, is going to be, given your preferences, 2 over g over 1 over b, which is just going to be 2b over g. What has to be true of this? Well, right, let's draw our little picture again. Well, we know that we're going to have an interior solution here, right? Because if we didn't have an interior solution, if we had no beefroni, we would have an MRS of 0. If we had no Gatorade, we'd have an MRS of infinity, right? So what this means is we can set our MRS equal to our price ratio. Right? This is going to tell me that 2by over gy has to equal pg over pb. This is going to tell me that by equals 1/2 of pg over pb times gy. What do I do from here? Well, it's been a little while, right? But what we're going to do from here is we're going to take this, we're going to plug it into our budget constraint. So we'll say PB times B plus PG times G has to equal 700 PB plus 50 PG, right? We can then say PB times 1/2 PG over PB times G plus PG times G has to equal this, right? The PBs are going to cancel. So we have 1/2 PG times G plus PG times G. This is 3/2 PG times G equals our income, which is going to tell me that G is going to be this thing divided by 3/2 PG, right? So we'll have 2/3 of 700 times PB over PG plus 50 times PG over PG, which is just 50, right? So what are we saying? We're saying that the amount of Gatorade we're going to consume is 2/3 of basically the value in terms of Gatorade of our endowment, right? The Gatorade value of our endowment. The amount of Gatorade we could buy with our Gatorade, the amount of Gatorade that we could buy with our beefaroni. And this is going to lead us to a value of By, right? Which is just By equals 1/2 PG over PB times GY. So this is going to be 1/2 of this thing. PG over PB times 2/3 times 700 PB over PG plus 50. So the 1/2 of the 2/3, right, cancels to be 1/3. We're going to end up having PG over PB times PB over PG. So this is going to be By equals 1/3 times 700 plus 50 times PG over PB. If we think about what this is telling us, it's telling us that the amount of beefaroni we're going to consume is 1/3 of the total amount of beefaroni that we could buy, right? Our 700 cans of beefaroni plus the amount of beefaroni that we could get for our 50 gallons of Gatorade. This makes sense? So now we've figured out how much Gatorade and how much beefaroni you would choose to consume, right, for any given set of PB and PG. Now we can do exactly the same thing for Wilma, right? So we'll say that Wilma's MRS, we found this a couple times, so I'm just going to skip to it, right, is going to be 2 times BW over GW, right? And we're going to say that Wilma's MRS is going to equal the price ratio. Right, so 2 BW over GW is going to equal PG over PB, right? BW is going to equal 1/2 PG over PB times GW. We'll plug this into Wilma's budget, right? So that'll give us PB times BW plus PG times GW equals PB times 300 plus PG times 450, right? Plug this in for BW. I'm going to end up getting PB times 1/2 PG over PB times G plus PG times G equals our income, right? Just as before, this is going to give me 3/2 PG times G equals PB times 300 plus PG times 450. Right? So then I'm going to get that Wilma's going to consume 2/3 of 300 PB over PG plus 450. in Gatorade, right? Just as before, this is going to be 2/3 of the total amount of Gatorade she could possibly afford, right? All of her Gatorade plus the Gatorade she could buy with her beefaroni. And we're going to get that BW is going to equal 1/2 PG over PB times this, which is going to be 1/3 of 300 plus 450 times PG over PB. Make sense? Great. So now we've got your demand curve, we've got Wilma's demand curve. At any given prices, we know how much Gatorade you're going to buy, how much Gatorade she's going to buy, how much beefaroni you and she are going to buy. So now that we know your demand and Wilma's demand at any given set of prices, all we need to do is find the prices that set our market into equilibrium. Right? In other words, we need to find the prices where the supply and demand of Gatorade are equal, where the supply and demand of beefaroni are equal. Right? So everyone walks in with their wheelbarrows full of stuff, buys and sells however they want at those market prices, walks away with what they want. Nobody ends up saying, gosh, I wanted beefaroni, but they were out. Or gosh, I wanted Gatorade, there was no Gatorade left. And there's no Gatorade or beefaroni rotting on the docks. Does this make sense? So before we're going to dive into this, I want to look at these demand functions for a second and notice something kind of interesting. What I want us to notice is that in all 4 of these demand functions, the only thing that matters is our price ratio, right? PB over PG or PG over PB. What this suggests is that if I doubled PG and I doubled PB, I would have no effect on any of these demands, right? Nothing would change in our story. So why is that the case? Why does this make sense? Well, if we think about what's going on, if we doubled our prices, double both of our prices, we're of course not going to change our price ratio at all, right? We won't change the slope of our budget constraint. But we also aren't going to change our effective incomes at all. The reason that we're not going to change our effective incomes at all is, yes, we doubled our prices, but also we doubled everybody's income. Because the amount of money everyone has, right, everyone's income, is the dollar value of their endowment. Right? So if beefaroni and Gatorade were both twice as expensive, that means that every single person is exactly twice as rich. And for this reason, we can say, and we can always do this, that one of our prices is going to be set by assumption to equal 0. And in this case, I'm going to pick the price of beefaroni. So I'm going to say, assume PB equals 0. I'm sorry, not equals 0, equals 1, right? We can set a price to do whatever we want it to be. And essentially what this means is, I'm going to say that the price of Gatorade is going to represent the amount of beefaroni you could buy for a gallon of Gatorade. Okay, so from here, all we have to do is find equalization of supply and demand, right? So all we're going to say is, let's look at the beefaroni equations, right? Because we've got 1/3 rather than 2/3. So we would simply say that your beefaroni plus Ma's beefaroni, right, has to equal 1,000. If this is true, our market's in equilibrium. So this will tell us that 1/3 times 700 plus 50 times PG, right? Remember, PB is equal to 0, plus 1/3 times 700, 1/3 plus 300 plus 450 PG has to equal 1,000. This makes sense? From here, right, we can just combine our terms. So we can say this is going to be 1/3 times 700 plus 300, so 1,000, plus our PG terms, right, 50 plus 450, so plus 500 PG has to equal 1,000. Right, let's multiply everything by 1/3, say 1,000 plus 500 PG has to equal 3,000, so PG has to equal 2,000, right? 3,000 minus 1,000 over 500, right? So what's our price going to be? Our PG is going to equal 4. This makes sense? What we're saying is that each gallon of Gatorade is worth 4 cans of beefaroni, right? We all have to give up 4 cans of beefaroni in order to get a gallon of Gatorade. From here, we can figure out what everyone's going to buy, right? Because now we know our prices, we had our demands. So we can say that the amount of Gatorade you're going to buy is going to be 2/3 times 700 over PG, right, over 4, plus 50. This is going to be 2/3 times, 700 over 4. It's going to be 800 over 4 would be 200, right? So minus 25, so 175 plus 50. So 225. This is going to equal 150, right? How about beefaroni? You're going to buy 1/3 of 700 plus 50 times 4, right? 50 times 4 is 200, so this is 1/3 of 900 is 300. How about Maud? Well, she's going to buy, Wilma. Wilma's going to buy 2/3 of 300 over 4 plus 450. This is going to end up being 350. And she's going to buy 1/3 of 300 plus 450 over 4. 450 times 4. Right? 450 times 4 is, what is that? 1600 plus 200 is 1800, 2100. 1/3 of 2100 is 700. Make sense? So we can notice that indeed supply equals demand, right? All of the beefaroni is accounted for, all of the Gatorade is accounted for. But there's another thing that I want us to notice, which is that you're buying twice as much beefaroni as you are Gatorade, and Maud is buying twice as much beefaroni as she is Gatorade. And what this tells us is that our solution to our competitive equilibrium just so happens to lie on our contract curve, right? In other words, we've ended up at an outcome here that is Pareto optimal. Even though nobody was trying to Pareto optimize, no one was negotiating with each other, right? All they were doing was buying and selling at a set of common prices. The thing I want to leave you with here is to think about why this is, right? Was this a coincidence? Or does it have to be the case, given any set of utility functions, any set of endowments, that we're going to end up with a competitive equilibrium on our contract curve? In other words, a Pareto optimal competitive equilibrium. In order to think about this, I want us to go back to the geometry of this problem. Right, so we said that from your perspective, we've got your Gatorade, we've got your beefaroni, right? We said that you're going to end up with a budget constraint like this that goes through your endowment, right? And that you're going to choose your best choice. I didn't draw that very well. You're going to choose your best choice, which just so happens to be, given what we had, $150 gallons of Gatorade and 300 cans of beefaroni, right? This is what your problem looks like. This looks just like all of the consumer theory problems that we dealt with in the first unit. Now, if we think about Maud isn't thinking about you at all, but as we said when we drew our Edgeworth box, Wilma is getting everything that you didn't get, right? So she has an endowment that is everything other than your endowment, right? Her endowment is going to have 450 gallons of Gatorade, and it's going to have 300 cans of beefaroni, right? Which means that her budget constraint is the same slope as your budget constraint because you share common prices. And it's exactly the same as your budget constraint but seen from the other side of the Edgeworth box. In other words, collectively, you and Wilma can afford to buy everything, right? Once we add up all the stuff you can afford, all the stuff she can afford, we're left with all the stuff that exists in the economy. Does this make sense? Both of you share this set of prices, which is PG over PB. Now what's Wilma going to do when she makes her optimal choice? She's going to do exactly the same thing that you did, right? She's going to look at this and she's going to say, well, given the set of prices, I'm going to choose to be tangent to my budget constraint, right? I'm going to choose my best choice. And that has to end up being Pareto optimal because of the fact that your condition for your best choice is that your MRS has to equal the price ratio. And her condition for being in her best choice is that her MRS also has to equal the price ratio. We put these together and we have to conclude that your MRS is equal to her MRS, which is exactly what we needed in order to say that we're Pareto optimal. So ultimately, what are we saying? What we're saying is that what prices are doing in this economy is essentially passing information between you and Wilma. Right? The more that you want Gatorade, the more you're going to bid up the price of Gatorade, the less Gatorade Wilma's going to buy. The more she wants Gatorade, the more the opposite is going to happen. Right? If we put all of this together, what we're going to end up with is a situation where you're collectively going to come to a Pareto optimal outcome, one where no one would benefit from trade, despite never being able to communicate with each other, or not having to communicate with each other. Okay, I've kept you over, so I'm going to leave it there. Looking forward to talking to you about this in class.